Hello, Chris Keyack here with Keyack Technology Solutions. In this video today, I'm going to showcase how to model in an asymmetrical base plate, but I'm going to focus more on how to manually model it. I do, however, want to show that base plate component 1047, which is pretty common for applying base plates and anchor rods, can actually accomplish this. And if you do a search for 1047 in the Applications and Components panel, there's going to be this corner BP with straight rods starter settings. So if I just click on that to activate it, click on the column, click on the bottom of the column here, which is the bottom of base plate insertion point, you'll see that we have that corner cut or asymmetrical L-shaped base plate. And then you'll also notice that there are anchor rods that are in an asymmetrical pattern. Now, Dave Hideman with Tekla has actually made a great video on YouTube about this. So I'm going to let him kind of showcase that more. I've linked that here in this video. But just to kind of overview what is required if you are going to use 1047 to do that is here, for instance, on the picture tab, there's these two fields here or in each corner, whichever corner you need the cope or the cut at. That will actually specify the depth or the size of that corner cut. Then on the parts tab, of course, you specify your base plate thickness and your size. And the parameters tab is where a lot of action happens. You need to tell it which corner you're going to actually be doing the corner cut in. And then this here ties back to that picture tab and the numbers you're filling in. And then the other big thing here that a lot of people don't quite understand is this whole eliminate bolt numbers. And Dave goes into this pretty well in telling you which bolt numbers, like on the base plate pattern, and which one's number 1, 2, 3, 4, and which ones you need to set to remove in order to create this asymmetrical pattern or this shape. Now, the other key thing here is that on the bolts tab, there is this offset that you're going to see. So if you ever have an asymmetrical base plate where it's not perfectly centered on the center of the column, then you have to actually enter in these offsets in either the X, Y, or the X and the Y direction relative to the column. And then you have your bolt spaces and your edge distances as required here. Now, that just kind of showcases a little bit of how it can be done using the component. But I'm going to showcase how to quickly model in a asymmetrical base plate and put in the bolts yourself, especially if you're just doing something really simple, want to get this done really quickly, and you don't want to have to spend like 10, 15 minutes trying to understand exactly how the 1047 one works for that scenario. All right, so now what I'm going to do is I'm first going to create a 2D view that is at the bottom of the column. If I double click on the column here, we can see that the bottom of the column and the bottom of the base plate is at -10.5 inches. Now, what I'm going to do next is I'm going to go up here to the view properties. So I'll go to view menu, I'll go to view properties, and then what I usually do is I have some saved away settings in my firm folder that are called temp. So when I load these up, you'll see that the name of the view has parentheses around it, which basically means that when I create these 2D views to just do some quick modeling and then I close them out, they're not going to be saved in my named or saved views list, which is exactly what I want here. Then I also tend to change the view depth down here to about 3 inches or so. So I'll apply those settings and press OK. Next, I'll go to New View and I'll go to Basic View. Then here in the coordinate, this is the elevation in the model in the Z elevation where I want this view to be created, where the view plane will be. And I want that at the bottom of base plate or at the bottom of the column. So I'll say -10.5 and I'll go ahead and say Create. So now I've got this 2D view that's created at -10.5 elevation, and then I've got my 3D view here over on the right. Now what I'm going to do is I'm going to just go ahead and model in a contour plate. So we'll go to the steel menu, and we'll go to the plate command, and here we can see that we can type in PL 1 inch, and there's our thickness of our plate, and we want the thickness of the plate to come towards us. We're modeling the bottom of the base plate at -10.5. All right, so now that I've got that set, what I'll do is when I look at this, really, I need to get to the corner of the base plate, right? And I don't really have anything to snap to. So I'm going to right click and say Define Temporary Reference Point. So I'll just go ahead and click here at the center of the column once I've done that. And this actually acts as a reference point that I can offset from. So now I'm going to type in R on my keyboard. So R is for relative. And then what I can do is I can type in an X, Y offset. So here I want -X, +Y for the top left corner of my base plate from that reference point at the center of the column. So there we go. And then now what I can do is I can just go over here to the right, and then I can just type in 28. And that's the length of my base plate. Then I'll just come out down here and I'll just do 16. And then I'll come back and I'll type in 28. And then I can middle mouse button and close out that plate and then interrupt. So there we go. Really quickly, I've got my plate in, and I might even come in here and just change like the class number to class number 1, which is pretty common for connections. And now I've got the starting point of here of what I want to do. Now, when I model in bolts, what I usually do is you'll see that I've actually got some properties that I've had set from before. So I always tell new users and trainees that when you're starting out with Tekla, just come in here and load standard at the top. And that'll zero out all the offsets and the dimensions that you tried to do from a previous bolt command. That way it's going to put the bolt right at the center point of the first point that you pick here. So let's go ahead and pick our plate, and then I'll middle mouse button because there's no other parts involved in the bolt group. And then what I'll do is I'll just pick right here at the center of the base plate, and I'll go to the other right-hand side center of the base plate. And like I said, there's the bolt right at the first picking point. So we'll interrupt. I'll then just click on that bolt here. And let's say that we are going to keep 3/4 inch bolts. Maybe I'll change the type here to just A307. We're not actually going to have structural bolts here. We're going to put in anchor rods through here, so we'll increase the size of these holes as required. But what I want to show is that I'm just going to come down here to this DX direction. So I picked my first point to the left here, my second point to the right, and that defines the positive X direction of the bolt group, regardless of the current work plane or the coordinate system in the model. Your first 2 picking points or your first point to your second point is basically the X direction in the bolt group itself. So I want an edge distance of 2 inches, so that looks good here. And then what I'm going to do is I'm going to do a gauge of 12 inches. So if the distance here and the line formed between these 2 points is the X direction of the bolt group, then the Y is going to be perpendicular to that. So here in the bolt distance Y, I'll just type in 12, and there we go. There is now a gauge of 12 inches in the Y direction between my bolts. Now here, what I'm going to do is I'm going to go ahead and get a 12-inch spread. So I'll just type in 12 for my first value here. But what I need is I need additional 6-inch spacings. So I need 2 more spaces, or actually, yeah, so 2 more spaces. So I'll do spacebar 2*6, and there we go. Now we have an asymmetrical base plate. Very easy for us to model. Now you can come in here and add any additional hole tolerance, based on whatever standard that you're using from the AISC manual and whatever the engineer is requiring. Here, this is kind of the old way, 5/16, and then I can just turn off the bolt solid here, and that will basically remove that and just leave holes behind for me. So there we go. We've got the initial base plate in, and we've got our holes in. Okay, so now that we've got that in there, we're going to go ahead and press Control-2 on our keyboard, and we'll see that the column is going down into the base plate. So we need to fit or cut that back. Now, what we can do is we can just click on the base plate, right click and say Create View, Default Views Apart. That will create 4 views for us. Now, if we have our views maximized, then it maximizes the last view that was created. So we'll come up here to the upper right-hand corner and press this Restore Down button. Now, when we do that, we'll see the 4 basic views. So I can close down any of these views here that I don't need, and I just need this elevation view. Now, what you need to do is you need to be in a 2D plane view in order to properly do a fitting here on the column. And I'm going to go ahead and go to the Edit tab, and I'll go to Fit Part End. Now, when I click on this, I'll see here at the lower left-hand corner that Tekla says pick on the part to be fit, which will be the column. And then down here on the lower right on my snaps, I've got Snap to Geometry Lines and Points turned on, which lets me snap to the corners and the edges of material. Now, what I'm going to do is I'm going to actually get in here and get at that intersection. Now, I can right-click and Snap Override and pick that. Or if I don't want to have to do that all the time, I can come down here to my snaps and just turn on Snap to Intersection Points. So that way that is on all the time. Now we've got that fitting in there. We'll right-click and interrupt. And here we can see that there is a fitting plane that has been applied to the model, and it cuts that column back. If we actually delete that fitting out, the column will go back to its original length. So that way you can adjust by the column length and the setback by moving that fitting up and down or deleting it. All right, now we've got that set. The last thing that we'll do here is we're going to go ahead and apply the weld. For the weld, what we'll do is we'll go to the Steel tab, and then we'll go to the Weld drop down here. Now there's a couple different ways that we can do this. We can use a simple weld, which all we have to do is choose the Create Weld Between Parts, or there's a Create Polygon Weld. I'm actually going to show both options here so you can understand when you might use the 2 differences. Now, what I'm going to do is I'm just going to say create weld here, and this is going to be a simple weld. And Tekla says select the part to weld to. Now, the order in which you pick is pretty important in Tekla. I want this base plate to be welded to the column, and I want the column to be the main part of the assembly. So I'm going to go ahead and click that first. Then I'm going to click on the base plate. And so it turns yellow and the column shaft turns orange. I'll right click and interrupt when I'm done. And now when I click on here, we can see that there's a weld between these two parts. So now these two pieces are joined together as an assembly. If I click on the column, right click and say Inquire Assembly, again, we should see that the main part of the assembly turns orange because that is what the piece on the assembly that's going to get the assembly mark. And it's also going to be the part on the assembly that the assembly drawing coordinate system is going to be drawn from. So we definitely want to make sure we pick the right order for putting in our welds. If you accidentally reverse that and you have a yellow column and an orange base plate, you can always click on the column, right click and say Assembly, set as new main part of assembly, and that will force the main part to be there no matter how you do the weld order. So whichever way, in case you accidentally mess it up or do it wrong or something happens with the welds, you can always reset the main part of the assembly as needed. Now I'm going to come back in here to this weld. And what we'll do is we'll just go to some save settings here and see if there's a fillet all the way around. So there's a fillet all around weld. And you'll see here that when we load those properties, it changes this edge or around. Okay, so you can either do on an edge or the all around weld symbol. Now when we do this, we're also going to change the weld size. Maybe we'll change this to 5/16 because this was a little bit thicker plate. And now we can see that the all around weld symbol is there. Plus it actually draws that all the way around the column. So now we have the weld in, but what I want to show you is some people will not do the all the way around weld. They actually want to do partial welds on each face or each side. So I'm going to go ahead and show that next. Now, in this particular case, we're going to use polygon welds and we're going to only do a straight weld on each side of the column, rather than trying to do an all the way around, including the radiuses at the corner of the column. So what we'll do is we'll select on the column, right click, hold down Shift on our keyboard and choose this Show with Exact Lines option. Now when I hold down Shift and choose this Show with Exact Lines option, it actually draws in the corner radiuses of the column. This can be also done, for instance, on wide flange shapes where you want to see the radius between the web and the flange. Now that we've got that in, we'll go up here to the Weld command here on the Steel tab, and we'll go into that dropdown, and this time we're going to choose Create Polygon Weld. When I choose this, we're going to make sure that this is set to edge and not all the way around like we had before. Now what I'm going to do is I'm going to pick the column, then I'll pick the base plate because that's going to be welded to the column. And then now with a polygon weld at the lower left-hand corner, you're going to see that it says pick the start point for the weld. Well, what I'm going to do is I'm going to zoom in here and I'm going to right click and say Define Temporary Snap Reference Point. I love this command. I'm going to click right here. And then all I got to do is if I have ortho on, so see how notice when I'm like kind of getting near the X or the Y axis, it actually snaps to that with the ortho. So if you press O key on your keyboard, you'll see down here at the lower right that the ortho will turn on. So O is turned on here right next to this S. All right, so I'm just going to come in here and I'm going to hover my mouse so that way the ortho kicks in, and I'm going to type in 3.5. And that actually sets the start point of my weld to be 3.5 inches over to the left. Then I'm going to right click and just say nearest and just hover over this particular edge, and I'll just type in 7. And then now I'll middle mouse button, and there is my weld. So that's how polygon welds work. You pick the two parts that you're welding together, and then you pick the specific points between those connecting parts of exactly where you want the weld to go. And this is a great way and how you actually do your partial length welds. So here the radiuses got redrawn. So let's just go ahead and bring those back so that way we can see those. So I'll just go ahead and say, hold down Shift and say Show Exact Lines. And there we go. Now we can see that that weld length is put in there. Then what we can do is we can just take this and we can say Copy Special. So we'll highlight that, right click, Copy Special, Rotate. And then what we'll do is we'll just say 90 degrees. We're going to do this 3 times for the copy. We're going to actually, we're going to rotate around the center of the column. So notice that I can't select the center of that column. It's kind of hard to do. Well, what I'm going to do is I'm going to do Control 4 on my keyboard, and that'll turn it solid. It's a neat little trick. When you then hover your mouse over a solid object, look what happens. It tries to get to the nearest or the closest snap, which here it's going to the member line, to the bottom of the column. So I'm going to go ahead and click on that, and that's my rotation location or origin. I'll then say copy, and then here we can now see that there are welds on all 4 sides, and that's pretty much how you do polygon welds. Okay, so now I want to reuse this base plate on other columns. So what I'm going to do is I'm going to wrap this up as a custom component. What I'm going to do is I'm going to window from left to right around the bottom of the column. Now I'm making my window pretty large here because I need to make sure that I grab this fitting or the cut plane that cut the column to the thickness of the base plate. A lot of times when people make custom components, they forget to grab this. They just come in here and start grabbing on parts by holding down Control, and they forget that. So I'm going to window from left to right and grab everything here. So I should have 4 welds, 1 bolt group, 1 plate. So that's 6 objects, and then 1 extra cut there, that's 7 objects. So here at the lower right-hand corner, I see 7 objects are selected, which is perfect. Now I'm going to come over here to the Applications and Components panel at the right-hand side of Tekla. And then there is here a little pancake or a stacked horizontal lines button. I call it the pancake button because it looks like a stack of pancakes. Customer gave me that one time, so I use it all the time now. People never forget it. So here under the pancake button, I'll go to this Define Custom Component. When I choose this, there are 4 different types of custom components that I can choose from. Now here we're going to be choosing a detail because details are where you pick one input part, such as a column, and I'm going to be applying cuts and materials and things to that. I'm not really connecting the column to anything else because there's no concrete in the model. I'm just putting in the base plate. So it's going to be a detail and not a connection. Now here, this might actually be your design drawing reference or whatever logical name makes sense for your custom component. You can't use inch marks in the name. In fact, watch this. See how if I type in a name and then I put an inch, you'll see that the next button actually gets disabled. So you can't use inch marks and you can't use dot, and I don't believe you can use slash. So the part of the reason is because when you export the custom components, the file name is usually by default the custom component name. All right, so we don't want to do that. So what we'll do is we'll just call this like BP1 as baseplate 1. But usually I use the design detail reference or some sort of baseplate schedule as a means of naming my custom components. Now, what we're going to do is we'll just go to the position tab. We're going to leave this at auto, so that way Tekla will auto rotate and place this based on the orientation of the column. And we're going to have the detail is going to definitely be an end detail because we're not applying multiple base plates along the length of the column. That would be more for something like an intermediate detail, such as stiffeners on a beam or something like that. This is going to be at the end or the bottom of the column, so we'll leave that at end detail. We want the custom component and all the parts and welds to be placed based off the center of the column. So we're going to leave the placement here at the center as shown. Now I'm going to say next, and then it says select the component objects, which we already did that. The component objects means all the stuff that's going to be created by this custom component. Press next, and it says pick the main part. Well, that's the part that you're attaching the base plate to. So I'll pick on that, press next. Then lastly here it says pick reference point or the main part. Now, if I know that this base plate is always going to go at the yellow start point of the column, then I'm actually just going to pick main part here. That way I don't have to pick the column and pick the bottom of the column to locate the base plate. This is really handy. So I'm going to choose main part here. I'll press finish. And now we should have that cone gets created in the model. So if I've got my selection here, we can select that entire component and you'll see that the welds, the base plate, the holes, and the fitting all get selected. And if I delete it, it will remove that. So I'll do Control Z to undo and bring that back. And now we have that as a component. Now, where did that component go? Well, it went here underneath this ungrouped items, and there's BP1. I can also do a search for BP1, and then I can right click and I can add this to my favorites if I want to, or add this into any groups that I want to for future use throughout the rest of the job. Now what I'm going to do is I'm just going to go over to the other side of this bracing bay, and I'm going to apply this on here. So I'm going to pick on the column, and notice that I did not have to pick the bottom of the column. It automatically knew to place this at the yellow start point of the column. That's the main part option that we chose when we defined the custom component. Now the only thing that I can see here that's an issue is that it's not rotated in the direction that we want. So you'll see here that the cone is pointing here in the positive y-axis. So if we look here at the work plane icon and the coordinate system icon, the tip of that cone is lined up with the positive y. Now here's a neat little trick. Rather than making a whole new custom component, I can just come in here and let's try to make the cone direction go to negative y. Now when I do that, it basically just inverts the coordinate system of that component and reverses it. And now I have basically like a copy rotate or a mirror about the center of that column. So that's a neat way for you to kind of just rotate like L-shaped base plates or these asymmetrical base plates for different scenarios or conditions on the job. Now, that is a better way to go rather than it coming in here and selecting on the column and changing the rotation. The reason why you don't necessarily want to change the rotation is, although this would probably work, so if I go from front here to back and modify, what that does is it actually changes the mark face for like if you put north and west on your columns for the shop to mark for the field exactly how to orientate columns when they erect them, then you don't really want to do this because you're actually changing the typical orientation of the column. So I don't usually do that. I usually come in here and I just change that the connection and the components coordinate system. So here again, I'm just going to go ahead, instead of leaving it at auto, I'll just do negative y. And now we have our asymmetrical base plate on both sides. Okay, now let's say that there was a design change. So what we're going to do is we're going to click on this base plate. We'll right click and say edit custom component. That's one way to get in there. Or what you can do is you can come over here to the applications components, find your custom component that you created, right click on it and say edit component. What this does is it creates 4 views for you that are titled Custom Component Editor, and it'll bring up these 2 additional dialog boxes. Now, we're not going to explain a lot about parametric components or binding things and stuff like that. We're just going to do the change. It's almost like we're editing this custom component or this 3D block, and then it's going to update all the instances in the model where this particular component has been applied. All right, so let's go ahead and quickly do those changes. I'm going to click on this base plate here, and I'm going to change this to 1.5 inches. So that was changed to 1.5 inches. And then what I need to do is I need to grab the fitting here, and I just need to move that up so that way the thickness of that base plate and the column setback has been adjusted. So we'll just go perpendicular here. Let's do intersection actually. And I'll come down here to the lower right and make sure my snap to geometry lines and points is on. And there we go. And it's just asking me to expand due to the view depth. And there we go, looks good. We've made that particular change. Now, I'm going to close down the custom component editor. So there's this toolbar here, and the far icon on the right, you say close editor, and it's saying, hey, I'm going to make these changes to all of the occurrences or instances of this custom component in the model. Say yes or no. I'm going to say yes. Now, when I do that and I go back to my main 3D view, you're going to see that the base plate is changed here, as well as the cut. And then also over here, even though this one is inverted 180 degrees based on the cone direction. So that shows you the power of manual modeling, wrapping things up as custom components where it makes sense and where it's applicable, especially if it's going to repeat more than 2 or 3 times across the job. And then you can edit that custom component to update and modify all of those at the same time, rather than having to deal with that design change one by one and modifying that in multiple places.